Radian and degree measure 1.1. So let's introduce angles first. We have an angle, and this is the vertex. We have initial side and terminal side. So the angle have orientation. So this is the orientation. The positive direction is the counterclockwise. We normally use angles in standard position. So angle is in standard position if the initial side coincides with the x-axis. So this angle here is in standard position. The initial side coincides with the x-axis. The terminal side is, in this case, in the first quadrant. So we have positive angles with direction counterclockwise and negative angles with direction clockwise. Definition of coterminal angles. So we say angles are coterminal if they have the same initial and terminal side. So these are angles that have the same initial and terminal side. They're different. So for example, here's an example of two angles. I'll call the first angle alpha. Here it is. And the second angle, I'll call it beta. One's positive, one's negative, but they both have the same initial and terminal side, so we call them coterminal. Another example, both angles are going to be positive. So the first angle is acute. Here it is, alpha. And the second angle is this one. We'll call it beta. They're both coterminal. Radian measure. So what's 1 radian? We'll start with a circle. And in the circle, we're going to cut an angle such that the arc that the angle cuts from the circle, this arc, is equal to the radius. So it's like equilateral triangle, but one of the sides is an arc. So I'll write this down, that 1 radian is the measure of a central angle, theta. Let's call this angle theta. 1 radian is the measure of a central angle. We call it central angle because the center or the vertex of the angle is at the center of the circle. So 1 radian is the measure of a central angle, theta, that intercepts an arc equal in length to the radius r of the circle. All right, so let's see. We saw how much is 1 radians. We know the circumference of a circle has a formula 2 pi r. We know 2 pi is approximately 3.14 times 2, 6.28. So half a revolution, so think about a circle, and half a revolution is this. Half a revolution is equal to 2 pi divided by 2, so pi radians. Okay, a quarter of a revolution, that's going to be 2 pi. 2 pi is the whole circle divided by 4, so it's pi over 2 radians, and so on. So if one radian is somewhere here, we saw that previously, that's the central angle, cutting an arc equal to r, then 2 radians will be somewhere here, 2 radians, so 3 radians, we're just mapping them up, approximately 4 radians, 5 radians, so we have 6 radians. Remember we said 2 pi or 1 whole revolution is 6.28. So we see how the radians match. Common angles. Angles that are very common in radians. Let's start with pi over 6. So how can we show pi over 6? If pi is half a revolution, so pi over 6 would be about 1/3. Here's pi over 6. Think about pi 180 divided by 6, that's about 30 degrees. Another common angle would be pi over 4. So pi over 4 is 1/4 of pi, 1/4 of half revolution. Here it is. Pi over 4, that angle. Another common angle will be pi over 3. So think about half a revolution divided by 3. Will be somewhere here. Pi over 3. Of course, pi over 2 is common angle. So this is pi over 2, or right angle. Then we have pi. This is half a revolution. And finally, 2 pi. So these are the common angles we're going to use a lot in trigonometry. Now let's connect those radian measure with a coordinate system. So we have here the x and the y axis. We know this is the first quadrant, the second, the third, and the fourth. In the first quadrant, the angles are between 0 and pi over 2. We saw pi over 2, 90 degrees. In the second quadrant, the angles are between pi over 2 and pi. In the third quadrant, the angles are from pi over 2 to 3 pi over 2. And in the fourth quadrant, the angles are from 3 pi over 2 to 2 pi. So a given angle theta has infinitely many coterminal angles. Let's write this down. A given angle theta has infinitely many coterminal angles, positive and negative. For example, if the angle theta, let's have theta pi over 6. This angle is coterminal with another angle, pi over 6 plus 2 pi. So you just add one revolution and get a coterminal. And I can multiply this by n and say n is an integer, which means 1, 2, 3, 4. So if we keep adding, it could be negative integer, or subtracting multiples of 2 pi, we're getting different coterminal angles. So example, sketching and finding coterminal angles. A, find the coterminal angle for 13 pi over 6. Okay, so one way to find another coterminal angle is either to add 2 pi or subtract 2 pi or multiples of 2 pi. So there is more than one way to do this. I'm just going to subtract 2 pi because I see 13 over 6 is more than 2. So it will be easy to do. We need the same denominator, let's multiply by 6. So I write this 12 pi over 6, the same denominator, so that's pi over 6. So pi over 6 is an angle that is coterminal with the given angle. So we either add or subtract multiples of 2 pi to find a coterminal angle. Another definition here that's familiar, complementary and supplementary angles. Complementary angles. First, so we say two angles are complementary if they add up to 90 degrees. So let's say the first angle is alpha, the other angle is beta. They don't have to be in the standard position, but they could be. So if alpha plus beta is pi over 2, we call alpha and beta, we call them complementary. They complement each other. Together, they equal to a right angle. And supplementary angles, these are angles that add up to pi. Again, they don't have to be in the standard position. I'm drawing them together here. So we have alpha and beta, and they add up to 180 or pi. We call them supplementary. So example, if possible, find the complement and supplement of. So if possible, find the complement and supplement of a 2 pi over 5. So it says if possible, which tells you there are some angles that don't have a supplement or a complement or either one. So with 2 pi over 5, if it has a complement, then both of them together will add up to pi over 2. So if I simply subtract the given angle from pi over 2, and if I find a reasonable angle, then I have it. So the same denominator should be 10. Let's multiply by 5, top and bottom in the first fraction, and the second fraction multiply by 2. So now they have the same denominator, 5 pi over 10 minus 4 pi over 10. So that's pi over 10. So pi over 10 is the complement of the given angle. To find the supplement, two angles are supplementary if they add up to 180. So if I subtract from pi the given angle, so that's 5 pi over 5 minus 2 pi over 5, and I got 3 pi over 5. So this is my supplement. The given angle is 4 pi over 5. Now, what I notice here, you can convert into degrees. We'll see that in a little bit, but I notice this is greater than pi over 2. Okay, well, if it's greater than pi over 2, then it has no complement. It's too big. To find the supplement, we do the same thing. We subtract from pi the given angle. So that's 5 pi over 5 minus pi over 5, pi over 5. And that is the supplement. All right, degree measure. You familiar with that? So what's 1 degree? 1 degree is 1 over 360 of a complete revolution. In other words, if you divide the circle into 360 parts, 1 part is 360. So we say 360 or 1 revolution is 2 pi radians. 180 or half revolution is pi radians. So that's how we convert back and forth. We can say the 1 degree is 1 over pi over 180 radians, and 1 radian is 180 degree over pi. So conversion between degrees and radians. And this is very, very important because we are constantly going to convert back and forth. So from degrees to radians, to convert from degrees to radians, multiply by pi over 180 radians. We're converting to radians. And now from radians to degrees, multiply by 180 over pi. I'm going to say here degrees. All right, quick example. Convert 135 degrees to radians. So we say we multiply by pi over 180 degrees and we cancel. So I can divide by 45 because I know 45 goes into 180 4 times. So that's 4, and 45 goes to 135 3 times. So that is 3 pi over 4 radians. Okay, so from radians to degrees, how do we do this? Let's do 9 pi over 2. That's in radians. We want to convert to degrees. We say we multiply by 180 over pi. We cancel the pi. We cancel everything else. So for example, 2 and 180, that would be 90. So 90 times 9 is 810 degrees. And that concludes 1.1 video lecture.